friends, welcome to this special video on quantum mechanical model and quantum numbers. This video is a continuation of chemistry chapter structure of atom. If you have not watched the other videos of this chapter, then please do that. So in this video we shall discuss the quantum mechanical model of atom, which is the current model of atom. In quantum mechanics, we speak about probability of an electron with a particular energy to be present in a certain region around the nucleus. So in the last lecture, we read about Heisenberg's uncertainty principle. This principle stated that we cannot predict the definite location of an electron, but we can only tell the probability of an electron to be present in a region. And this is all about the quantum mechanical model. There are certain regions around the nucleus where the probability of finding the electron is high, and there are certain regions around the nucleus where the probability to finding the electron is low. The regions around the nucleus where probability of finding the electron is maximum are called orbitals. So the concept of orbitals was the new concept in quantum mechanical model. This concept stated that the region where the probability of finding the electron is highest, that is around 90 to 95%, that region is called orbital. So let's discuss quantum numbers. Atomic orbitals are precisely distinguished by quantum numbers. Quantum numbers are just like the address of electrons. Just like if anyone has to find you, then he must know the address of your house. Similarly, to find an electron, we must know its quantum numbers. So, in a house address, we have city, locality, house number, etc. Similarly, for the finding the address of electrons, we have different types of quantum numbers. They are called principal quantum numbers, azimuthal quantum numbers, magnetic quantum numbers, and spin quantum numbers. So if we know all these quantum numbers of an electron, then we can easily locate an electron in an atom. This video will be all about these quantum numbers. First, principal quantum number, denoted by n. It determines the size and energy of the orbital in which the electron resides. That is, the size and energy of orbital will increase with the increase in principal quantum number. So if the n will increase, then so will the size and energy of the orbital. So this means that the size of and energy of an orbital with n is equals to 2 will be more than that of n is equals to 1. N also represents the shell number. That is, principal quantum number determines that in what shell the electron is present. N can have different values like 1, 2, 3, 4, etc. And we also have some names for these shells. The first shell is called K shell, second shell is called L shell, third shell is called M shell, and fourth shell is called N shell. Now, within a shell, there are subshells, and the number of subshells within a shell is given by the second quantum number, that is azimuthal quantum number, denoted by L. The values of azimuthal quantum number L depends upon the values of n. The possible values of L are 0 to n minus 1. So L can have any values between 0 to n minus 1. Now we have some subshell notations for the different values of L. If L is equals to 0, then the subshell is called S subshell. If L is equals to 1, then the subshell is called P subshell. If L is equals to 2, then we have D subshell. And if L is equals to 3, then we have F subshell. Third, magnetic quantum number, denoted by M. It gives the number of orbitals in a subshell and also tells us about the orientation of orbitals. That is, whether the orbitals are present in x-axis, in y-axis or z-axis. For any subshell, magnetic quantum number m is equals to minus L to plus L. So S subshell has m is equals to minus 0 to 0, that is 0. Because in S subshell, the L is equals to 0. So therefore, as m is minus L to plus L, so m will become minus 0 to plus 0, that is 0. And the second subshell, that is P subshell, it has L is equals to 1. So therefore, m will become minus 1 to plus 1, that is, it will have three values, minus 1, 0 and 1. And D subshell has L is equals to 3. So, D subshell has L is equals to 2. So therefore, m will have values from minus 2 to plus 2. That is minus 2, minus 1, 0, 1 and 2. So m can have all the values that are between those two numbers. And the m determines the number of orbitals in a subshell. Fourth, spin quantum number, denoted by S. Now, apart from revolving around the nucleus, the electrons also spin around their axis. So, this quantum number is called spin quantum number. It can have two values. That is, S is equals to plus half and S is equals to minus half. S is equals to plus half is the value when electron spins in clockwise direction. And when the electron spins in anti-clockwise direction, then the value of spin quantum number becomes minus half. And spin quantum number is also denoted by upside arrow and upward arrow and downward arrow. So now let's summarize all the four quantum numbers. So here we have shell that is determined by N. Here we have subshell that is determined by L. Here we have magnetic quantum number. Here we have orbitals that is denoted by magnetic quantum number. And here we have the number of electrons. So let's fill this table and understand better. So first let's discuss first shell, that is N is equals to 1. So if N is equals to 1, then what will be the value of L? So value of L will be 0. As N is equals to 0 to N minus 1. And 1 minus 1 is nothing but 0. So therefore the value of L will be just one value, that is 0. Now value of M will be minus L to L, that is minus 0 to 0. So again it is 0. So value of L becomes 0. So as there is one value of M, this means that there will be one orbital. So basically, for every value of M, we will have one orbital. If M is 0, then we will have one orbital. If we have two values of M, then we will have two orbitals. If we have three values of M, then we will have three orbitals, just like that. And the number of orbitals further determines the number of electrons. Every orbital can maximum have two electrons. So therefore, as there is one orbital in the first shell, so therefore there will be two electrons. So this was all about the first shell. And also, as I have told you before, that whenever L is equals to 0, so that subshell is called S subshell. So the name of the subshell will be S. Now let's discuss what happens when N is equals to 2. We have the second shell. So N is equals to 2. Sorry, N is equals to 2. Shell number is equals to 2. So if N is equals to 2, then what will be the value of N? It will be 0 to 2 minus 1, that is 1. So 0 and 1. So in this time, L will have two values, that are 0 and 1. Because L will have all the values from 0 to N minus 1. Now as there are two values of subshells, so we will have two subshells. We will have S subshell and P subshell. And again, let's see the magnetic quantum numbers for both of them. So for L is equals to 0, again we will have M is equals to 0, and for L is equals to 1, we will have M is equals to -1 to +1. So again M will have 3 values this time. M will have -1, 0 and 1, because M will have all the values from -L to +L. Now as there are 3 values of M, this means that there are 3 orbitals present in the p subshell. And in s subshell, as there is only one value of M, so 1 orbital. So total there are 4 orbitals. And now as every orbital has 2 electrons, so 2, and here we will write 3 into 2, that is 6. So completely the second shell will have maximum of 2 plus 6, that is 8 electrons. So maximum the second shell can have 8 electrons. Now let's discuss about when what happens when shell is the third shell, that is n is equals to 3. So now first pause the video and try filling the table for n is equals to 3 on your own, and then we will solve it. So now I am telling you the solution. So as n is equals to 3, this means that values of the subshell, that is L, will be 0 to 3 minus 1, that is 2. So it will be 0, 1 and 2. 0, 1 and 2. Now for 0 we know that it is denoted by S. For 1 it is denoted by P, and for 2 it is denoted by D. So we are having 3 subshells: S subshell, P subshell and D subshell. Let's separate them. And now let's find out the number of orbitals for each subshell. Now for S subshell, as we have M is equals to 0, so there will be 1 orbital. For P subshell, we have again calculated the values of M is -1, 0 and +1, and number of orbitals as 3. And now for D subshell, can you tell me how many orbitals will be there? So as for D subshell, it has L is equals to 2, so therefore M will be -2, 2 plus 2, that is -2, -1, 0, +1 and +2. So basically, as there are 5 values of M, this means that there will be 5 orbitals. And again let's calculate the number of electrons for each subshell. So as there is 1 orbital in the S subshell, so it will be 2 electrons. For P subshell, 3 into 2, that is 6 electrons, and for D subshell it will be 5 into 2, that is 10 electrons, because each orbital has maximum of 2 electrons. Now the total number of electrons will become 2 plus 6 plus 10, that is 18 electrons. So here we have completely filled this table, and similarly we can find the values of L, M and number of electrons when n is equals to 4. You can try it on your own. Now on the basis of this table, let's see few important formula which we can get. So one important relation from here we can get is that the number of orbitals is equals to n square. So here you can see that when n was 1, the number of orbitals was 1 square, that is nothing but 1. And when n was 2, then the total number of orbitals were 4, that is 2 square. And similarly when n was 3, then total number of orbitals were 9, that is 3 square. So number of orbitals is equals to n square. And as in each orbital there are 2 electrons, so this means that number of electrons is equals to 2n square. 2n square. So if we know the shell number, if we know the value of n, then we can easily find out the number of electrons by using this formula, that is 2n square. But if you want to solve it mathematically, then you can use this method also by making the entire table. So let's check it out. So let's see that if we take the value of n is equals to 3. So with this formula we can say that number of electrons will be 2n square, that is 2 into 3 square. 3 square is 9 and 2 multiplied by 9 is 18. So here you can see that we are getting 18 electrons. Now apart from the shell number, we can also get the number of orbitals and the number of electrons from the subshell number. So from the values of L also we can tell the values of orbital and electrons. Now let's see the formula for that. So number of orbitals is equals to 2L plus 1. Let's check it out. So if L is equals to 0, then you can see that if we put it in this formula, then we will get that 2 into 0, that is 0, plus 1, that is 1. So we will get 1 orbital, and which we are getting in this case also. When L is 1, then you can see that we are getting 2 into 1, that is 2, plus 1, that is 3 orbitals. And similarly you can verify for L is equals to 2, L is equals to 3, and L is equals to 4 also. And number of electrons will be just the double of number of orbitals. So number of electrons will become 2 into 2L plus 1. That is 2 into number of orbitals. So I hope that using this formula you will be easily able to find all the answers to the questions. So this was all about this lecture. In the next lecture, we shall see how we fill electrons in the orbitals using all these quantum numbers.